Hey folks, so in this video my cat is going to cast a shadow across the page. Brutta, my dog, is going to come in and try and figure out what I'm doing here. He gets very agitated when I sit in this particular chair, so you may hear him every now and then. Hey boy, good boy. Okay, go away. I love you, go away. In this video, I am going to draw the life cycle of a member of the Bryophyta. And the Bryophyta are our most abundant and diverse representatives of the non-vascular plants. And being non-vascular is a plesiomorphic condition in the plants. It's thought that the very first organisms that we could truly call plants and no longer call charophytes would have been non-vascular. Okay, so these are the true mosses, not to be confused with some things that are called moss colloquially, but are not mosses at all, like Spanish moss that grows on trees a little bit further south from where we are. That's not a moss at all. That's actually a flowering plant. It's a bromeliad, which means its closest relative that you might be familiar with is a pineapple, as it turns out. Irish moss is actually an algae, and reindeer moss is actually a lichen. So it's not a reindeer, it's also not a moss, it is something else entirely that we'll get into in Unit 3. So, remembering that in all of our life cycles, it's all about going back and forth between being diploid and haploid through mitosis, and then haploid to diploid through fertilization. I'm going to fuse some gametes to go from haploid to diploid. And because all plants have sporic meiosis, we're going to start with some spores. And spores are dispersal units, essentially made up of single cells, or maybe if they divide by mitosis a little bit to become haploid, few-celled things. But the important thing is that they are produced by meiosis, which means they're haploid, and they're going to grow by mitosis. I'm going to do this all twice, for reasons that I'll get into in a moment. So by mitosis, they're going to grow and divide into a structure called a protonema, or if we have more than one, they are protonemata. So these are Greek word roots that means first, thread. So there's a protonema, so two protonemata, and they're going to continue to grow by mitosis to produce I'm going to draw kind of a stick moss. You kind of probably have a good sense of what a moss looks like. You've probably seen moss before. Maybe you haven't taken a good close look at it. Had to know what it's doing out there, but here's a day that is not true anymore. Now we need to pay attention to what's happening in our moss. So here it is. So we'll draw like a little thing up there. It's kind of like a circle with a little stick coming out of there. And here we're going to draw a little kind of U shape, and we're going to put a couple little sausages in there. So these two things are two different kinds of moss gametophytes or moss plants. This one here is going to be our male gametophyte. Or gamete-producing plant. And over here we're going to have our female gametophyte. And I'm not going to tell the whole story about how I learned that this is the male symbol and this is the female symbol, but if you get confused, you might think of the male symbol. What it actually is supposed to be a shield and a spear, because back in the high and far off times, men were warriors and they'd carry their shields and spear. I always think it looks kind of like a circle that's kind of very excited to see you. And the female symbol is a circle with a kind of a plus hanging down from it. And that actually represents Venus's mirror, because I guess women like to look at themselves in mirrors, which, you know, there's a hot take. I look at it, I'm like, oh, it looks like a circle that's giving birth to a baby plus. So that's how I remember the difference between the male sign and the female sign. Whatever helps you, though, either of those stories is good to know those symbols. But why do we need to have a male gametophyte and a female gametophyte? Well, it turns out both of these plants are going to produce the gametes. That's their job. So if I were to zoom in on what's going on up here, on this little detail up here, what we'll see is that there's some inside that U shape with those sausages in there. The U-shaped thing, that is a structure called a splash cup that not all mosses have in their male gametophytes, but often they do. And that splash cup is there to kind of hold water because the sausagey things that are inside there, hi Macilio. Macilio, what are you doing? Uh-oh. Now they're both here. They're gonna keep themselves entertained for a while. So these little sausage-like things are called Antheridia, Antheridia. One is an antheridium, but they usually travel in groups called Antheridia, and these produce sperm by mitosis. You might say, sperm, those are gametes. How are we making them by mitosis? And that's just a thing that plants do. They make their gametes by mitosis. Okay, and if we zoom in on the apex, the top of our female gametophyte, we're going to find is that there is this structure at the top of our female gametophyte, and this is called an archegonium. Oops, Archegonium is how we spell archegonium. And archegonia, we're going to see these in lots of plant phyla, but the archegonium produces and contains the egg. I'll just draw a line from this little circle in there is the egg. And that's also produced by mitosis. Produced by mitosis. And one thing about these non-vascular plants is how reliant they are upon there being a ready source of water around, because they don't have conducting tissues. These little things that are anchoring the plant to the soil, the gametophyte to the soil, those are not roots. They are structures called rhizoids, which means they are root-like, and that they anchor the plant to the ground, but they don't actually conduct water up into the stem, because that's a thing that vascular tissue does. These little things that are on there, they look kind of leafy, but they are not leaves, because leaves have vascular tissue in them. and there's not a true stem with vascular tissue in there either. So non-vascular plants have no vascular tissue, so they rely on water being around to do things like keep the plant hydrated, as well as to transfer sperm from the antheridia to the archegonia. And when that happens, isn't that great? It's supposed to be that same exact thing, but now instead of being an egg, that is now a zygote because fertilization has happened. Let's make a note here. Water moves sperm from antheridia to archegonia. And that's how we get fertilization. All right, so we still have this archegonium that's at the top of our female gametophyte. So I'm going to kind of redraw our stick moss on here once again. And one more time. Okay, so here's the base of the archegonium. And now we are going to be in the sporophyte generation. So mitosis is going to take that zygote and convert it into our sporophyte. And everything on the sporophyte is going to be diploid except one little thing that I'm going to show you once I get to the end, okay? So down here, the sporophyte is anchored in the top of the female gametophyte. Again, that's haploid, by a structure called a foot. The foot connects to the seta, which is essentially the stalk that connects the foot to the capsule, which is where the spores are produced. Capsule, which is up here. Inside the capsule, we've got sporogenous tissue, which is where the meiosis happens. Makes things go from haploid to diploid inside that capsule. And then at the end of the capsule, away from where the seta connects, we've got this area that's called the peristome. And inside the peristome, we've got these structures called peristome teeth. And the peristome teeth, yes, they are diploid, but they're also hygroscopic. And hygroscopic is a word that means it changes shape or form in response to changes in moisture or humidity. So the significance of that status of being hygroscopic is when the air is very moist or very humid, these peristome teeth will start moving to kind of waft the spores out of the capsule so that they can go and find a nice place, hopefully where there's some water around, so they can grow by mitosis into protonemata and then into new gametophytes. All right, but there's a couple of other things going on here. One is there is a structure that is common, which is kind of like a lid, and that is called an operculum. And we're going to see opercula later on. It's a very common sciencey way of calling something a lid that covers the mouth of the capsule, the peristome, before the spores are completely ready and mature, because this all takes time to grow and develop through mitosis. And then often, not always, but often, there is this other covering structure called a calyptra, C-A-L-Y-P-T-R-A, which is, unlike everything else in here, it is haploid, because it is actually made by tearing the top off of the archegonium, and then it keeps growing. So from the female gametophyte, so it's the one part of this whole sporophyte that is not diploid but haploid, because essentially you can imagine these tear marks here come from being torn off the top of the female gametophyte. So that's our complete life cycle for a true moss in the phylum Bryophyta. Yeah, so there you go.